be talking about the introduction of sets. What are sets? Now, when we say a set, it is a collection or group of well-defined objects or things that follow a certain common rule. Now, take note of the word well-defined. It means specific, certain, standardized, and many people can agree. Let's take, for example, a set of Southeast Asian countries. This example is a set because of the word Southeast Asian, meaning it is specific. We are only referring to Philippines, Vietnam, Indonesia, Malaysia, and other Southeast Asian. Another example, a set of counting numbers less than 3. This example is also a set because it is particular. We are only talking about numbers less than 3, and those are 1 and 2. Now let us have the last example, a set of difficult subjects. Now, in this example, it is not a set. Why? Because of the word difficult. We all have different perspectives of different subjects. We all have different opinions, feelings. So I may be having difficulty in math or science or any subject, but for you it's easy. Meaning it is not standardized. Meaning not all people can agree. So it is not a set. Now let us move on how to name a set. In naming a set, we denote it by the use of capital letters. So we say set A, set B, set C, and so on and so forth, as long as the letters are in capital letter. Now let us have the elements of a set. Elements are the members or objects of the set, and it is represented by this symbol. For example, Y is a set of stringed instruments. Those stringed instruments, we have guitar, violin, and ukulele. So we say guitar is an element of set Y, violin is an element of set Y, and ukulele is an element of set Y. So now let us have the cardinality of a set. Cardinality refers to how many elements are there in a given set. It is denoted by this symbol. Now let us move on to methods of writing sets. Now there are two methods. First, we have the roster method. Roster method is a method where each element is listed and enclosed in a pair of braces. For example, W is a set of counting numbers between 1 and 5. So in roster form, we write it this way. Set W is a set of 2, 3, and 4. Next example, X is a set of planets in our solar system. So set X, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now let us have the next method, which is the rule method. So this method, it is written in the form X such that X is A or N, the description of the given set. Let us have the example a while ago. Set W is set of 2, 3, and 4. So in rule method or in set builder notation, we write X such that X is a counting number between 1 and 5. Now let us go to the types of sets. Now first we have the finite set. When we say finite set, it is a set where the counting comes to an end. For example, we have this set J, set of 1, 2, 3, 4, 6, and 12. Now this is an example of finite set because the elements are only referring to the factors of 12, meaning it is not infinite. Next type, we have the infinite set, where counting never comes to an end, meaning it is endless. For example, set L is a set where x such that x is a counting number. Counting numbers have no end. Imagine we have 1, 2, 3 to infinity. Next type is the empty set, where it is a set without an element. Take note of the word without. It is denoted by the pair of braces or in this symbol, and it is also called as null set. For example, a set of months that starts with letter B. Now, we don't have a single month. There is no single month that starts with the letter B, so it is an empty set. Lastly, we have the universal set. These are sets that has all the elements denoted by the capital letter U. Now let us have the subsets. Subsets mean that every element of X is an element of Y. So it is written in this symbol. Now we also have a proper subset. It means that if Y has one element that is not found in other set, which is Y, therefore X is a proper subset of Y. It is written in this symbol. For example, set K is a set of 1, 2, 3, 4, and 5. And the other set, J, is a set of 2, 4, and 5. Now, in this example, we say that B is a subset of A, or J is a subset of K. J is a subset of K since elements in J are also found in K. K is a proper subset of J because not all elements are found in J, which are 1 and 3. Now let us move on to the next, which is the equality of sets. Now we say that two sets are equal if these sets have the same elements, exactly the same elements. For example, set J we have a set of 1, 4, and 3, and in set J we have 4, 3, and 1. Now since these sets have exactly the same elements, though not in order, but still the elements are there, meaning these two sets are equal. Now let us move on to the equivalent sets. We say that two sets are equivalent if the sets have the same number of elements in the set or the same cardinality. For example, set W we have set of 1, 2, 3, 4, and 5. And set F we have set of A, E, I, O, U. Now let us count the elements of set W. We have 5 elements. And in set F, we also have 5 elements. Therefore, we can say that set W and set F are equivalent. Now let us have disjoint sets. Disjoint sets. These refer to sets that have no common elements. Let's take for instance this set L. We have set of 1, 3, 5, and 7. And set G, we have 2, 4, 6, 8, 10. Now we can see both sets have no common elements. Therefore, these sets are disjoint.